Hi guys, so in this video I'm going to go through the Year 12 Mathematics Standard HSC trial paper, the CSSA one. In this video I'm not going to be going through every single calculation. What I'm more going to be focusing on is explanations of how to do each question. So I have got my own solutions to the side, so to speed it up a little bit. We're just going to jump right into it. So question number 1, the multiple choice sections. So question 1, Amy is paid by commission only for working as a salesperson. Which of the following situations will ensure Amy earns more money? Well, this is commission, so as we know, commission is based on like a percentage of goods sold. So the way that you earn more money when you're earning on a commission is by increasing the amount of sales that you make. So that's number 1. Question 2 is a weighted network is shown below. What is the weight of the minimum spanning tree? So what we're not doing here is just adding up all the numbers and then that's it. We want to find the weight of the minimum spanning tree. So remember, to do that, we'll go through the algorithm. So starting at any point, let's start with J, and at J we can only go to K. And then next we need to look at all the connections. So next is 4. And now from here we need to look at all the connections again. Now we're not just going to jump to 6 because of course 5 is a better option. So 5 is where we'll go next. And then lastly, looking at all the connections here, the smallest one is 1. And there we go. We remember there's also the idea that here we have 5 vertices, 1, 2, 3, 4, 5. So that means the spanning tree should have 4 edges, and we got 1, 2, 3, 4. So that is the minimum spanning tree. All we need to do now is find the weight. So adding up the weights of each of those, you get 12. All right, going into the next question. So it's asking us, like, the graph of y equals 3 to the power of x is, and it's asking what kind of function it is. It's not a straight line because it's not linear. It's not a parabola either because it's not x to the power of 2. It's not a hyperbola because hyperbola means it's something over x. So that means it has to be an exponential. Plus also because x is the power, that's what makes it an exponential. Going into the next question, the total cost paid for fuel varies directly with the number of liters of fuel purchased. Which of the following graphs best represents this variation? Well, it says varies directly, and that pretty much answers the question for you. Remember, direct variation is linear, and it also starts at the origin. So that means it's A. Remember, direct variation is talking about as x increases, y also increases. Always starting at 0, always in a straight line. Inverse variation was when it's like curved down like that, but it's asking for direct variation. Going into the next question here. So it's saying Angus has received 4 quotes for the cost of a new carpet to be purchased and installed in his bedroom. And what you just need to do here is look at which option is going to be the best. So we're told that it's a 3 by 5 meter bedroom. So 3 times 5 equals 15 meters squared. So that's going to help with all these calculations. And from here, it's just a simple matter of doing each of these and seeing which one's the cheapest. And you'll find that B is the cheapest option. Looking at this, the area of New South Wales is that number. What is the area of New South Wales when written in standard form corrected to significant figures? Now remember, standard form is when it's like some number times 10 to the power of something, right? So straight away, that doesn't really help us too much. They're all saying times 10 to the power of something, but it also says corrected to significant figures. So straight away, we know it's not that, that's 4 significant figures. Same here, it can't be that. So now it's just between these two, because that's got 2 sig figs and that's 2 sig figs. But looking at this one, if we're rounding this to 2 significant figures, we're starting at the 8, going across, and then 1, and because it's 1 after the 0, that means we're going to round down, so that means it's 8.0. It's not 8.1 because that means you rounded incorrectly. Going to question 7. So Mr. Miller gave his Year 7 mathematics task a topic test. On the first attempt, the class had a mean mark of 65 and a standard deviation of 5. The class was given a chance to sit the test again, and every student improved by exactly 20 marks. So which of these would be correct? So we're saying that because every student increased by 20, of course the mean is going to increase. So straight away, it can't be that, and it can't be that. right? Because if everyone's getting 20 marks more, the average is obviously going to increase. The only thing we now decide now is whether the standard deviation is going to change. Now remember, standard deviation is a measure of spread. And so if every student increased by 20 marks, that means the marks haven't been spread out any differently at all. It's just at a different place. So that means the standard deviation is going to stay the same. Hence why the answer is C. Going into this question, we have a lighthouse 15 meters across and 15 meters tall and 80 meters across. So what we need to do is find the angle of depression. Now with all these kinds of questions, remember it's always recommended that you just draw your own right angle triangle because it just makes things, easier. So we have 50, we have 80, and we're trying to find the angle of depression. So that's that angle in there. Now remember, the angle of depression is always equal angle to the angle of elevation. So now that we have this is just a simple SOHCAHTOA problem. So tan theta equals 50 over 80. So theta equals inverse tan of 50 over 80. And when you put that into your calculator, you'll get 32 degrees. Now going into the next question, this is a Pareto chart, something that doesn't really pop up too much, but it's still good to know. Because obviously it could pop up in your exam. So the Pareto chart shows some reasons why learner drivers at a particular testing center failed their driving test. Approximately what percentage of learner drivers failed because they did not stop completely? Well, so we've got percentage, and remember that along here is the cumulative percentage. Now cumulative is the important word there, meaning it's always going to end at 100%, but we also need to consider, because it's cumulative, it means this is always going up. So what's best to do with this question is just look where this first dot is. We're looking at failing to stop completely at stop signs. So we're looking at this, right? So what I'm going to do is I'm going to look at what percentage is for that first one, for speeding. So you can see based on this, about 39% of student drivers are failing because they're speeding. And then looking at this one, we can see that's about 62% or something like that. So you can maybe say that's 38, maybe that's 62. And then we're saying that, remember this is cumulative percentage. So this 62 is saying that 62% of drivers are failing because of speeding or by failing to stop at the stop signs. But here we're just focusing on just the stop sign. So we're looking at the difference between these two. And then so if that's 62 and that's 38, so that means there's 24% in between those two. So simply 24%. The key to this one is remembering that this is cumulative percentage rather than the actual percentage. Looking at question 10. So the world's largest passenger plane is 73 meters long, and then the toy is 36.5 centimeters long. So we want to find the scale to this. And remember, to find a ratio or a scale, they need to be in the same units. So let's first of all write this as 7,300 centimeters. So 73 meters is 7,300 centimeters. And now we can write this as a ratio, so 36.5 to 7,300. And then simply got to simplify this ratio, and the way that we simplify ratios is just divide both by this number. So 36.5 divided by 36.5 is 1, and 7,300 divided by 36.5 is 200, giving us C. Going with this question now, what is the value of blah, blah, blah? Now this is that classic problem that I bet you a couple of students got wrong just because they kind of sped ahead and didn't actually pay attention to what they were doing. Specifically, we're saying we got a square and a negative number. And if you just go -5 squared minus -3 in your calculator, you're going to get it wrong. And this is something that we've kept talking about, but again, I'll recap why. Your calculator is going to read this as, okay, I'm going to do 5 squared and then put a negative in front of it. But that's not what we actually want to do. We want to do -5 squared. And then we could put brackets around that as well. So -5 squared equals positive 25, and then minus -3 is the same as plus 3, so that just equals 28. Looking at this question, so the price of a loaf of bread is $2.85. and is only increasing due to inflation at that rate, what is the expected price of loaf of bread after 14 years? Inflation, as we know, is just compound interest. So this is just a simple matter of this. The amount would be $2.85, so that current amount, times by 1 plus 0.013 to the power of 14, because it's after 14 years. And this would be about $3.41, which is your answer. So for that question, you just need to remember that inflation is based on compound interest, not simple interest. Now looking at this question, so I'm going to summarize what the question is saying, but basically it's saying a card was drawn from a deck of cards and then replaced, and this was done 20 times, and they recorded the results here. Now, what we're doing in this question is we're comparing the theoretical probability to the experimental probability. The theoretical probability of each of these is 1 over 4, 1 over 4, 1 over 4, 1 over 4. That's pretty basic. But the experimental probability, well, we did it 20 times, and 5 of those 20 was hearts, 4 of these 20 were diamonds, 4 out of 20 were spades, 7 out of 20 were clubs. Now, as I was doing my original solutions, I was getting stuck on this because I didn't read this big word in capital letters, false. So you need to see which one is false. So Kate's experimental probability was equal to the theoretical probability for hearts. Well, that is true. They aren't equal. I mean, 5 over 20 simplifies to be 1 over 4. So that's true. Kate's experimental probability was lower than the theoretical probability for diamonds. That is true as well. 4 out of 20 is lower than 1 out of 4. Kate's experimental probability was higher for spades, and that's not true. So 4 out of 20 is smaller than 1 out of 4. I just said that, so that means that's the answer. That's false. And just checking this last one, the experimental probability for clubs was higher than the theoretical probability. Yes, it was. 7 out of 20 is greater than 1 out of 4. So A, B, and D are true, but we're asking which one's false. So C. Now looking at this question, given that sine theta equals and theta is obtuse, what is the size of theta correct to the nearest degree? What we can do here is just put in theta equals, because we're just solving this equation, right? So to get rid of the sine, we're going to do inverse sine. So theta equals inverse sine of 10 times sine 70 over 20. And when you put that into your calculator, you get about 28 degrees. Now, that's not the answer, though, unfortunately. That's not one of the options here. We're told that theta is obtuse. So that means we now need to do that last change. So the obtuse theta, as we know, is you just do 180 degrees minus the acute theta, which is 152 degrees, D. And then lastly, looking at this question. So we have this diagram, this weighted diagram with all the activities, and what we need to do is find the float time of E. Now, what you don't need to do, like, we're also told in this question that the minimum completion time is 24 days. If we weren't told that line, we would have to do the whole forward scanning process and then the backward scanning process and then find the float time of E. But because we're told that the minimum completion time is 24 days, that straight away tells us that's 24 at the end, saving us all that time. And now we're only focusing on E. So if we can find the earliest starting time and the latest starting time of E, that means we can find the float time. So if we going backwards, first of all, 24 for K, we got 24 minus 3 is 21, and then going this way, 21 minus 5 is 16. So we found the latest starting time for E, but let's also find the earliest starting time. So this is obviously starting at 0, and after activity B, the earliest starting time for E is 4. So now we have the earliest starting time, the latest starting time, so therefore the float time simply is C, 12 days. So 16 minus 4. All right, so that's it for the multiple choice section. Let's get into the free response section 2. So starting us off, we just got to do a scatter plot and then put in a line of best fit for this question. So this is a good one, nice easy one to start us off. We just got to put these in. So January is 3, February is 6, March is 5, April is 4, May is 6, June is 8, and July is 7. So now we have these, and that's part A done, and that's 2 marks just for doing that. Pretty easy. And now we need to draw a line of best fit by I from the scatter plot. Now this is where there's going to be a bit of variation between your answers, but as long as it's mostly correct, it's fine. So remember, by I, all you need to do is just kind of draw some lines so that it goes through, the kind of same direction of the points, and half of the points are above, half of the points are below, if you can try to work that out. So I'm just going to draw a line, something like that. Okay, doesn't need to be too detailed at all, but of course you should have your ruler and you should be using your ruler. Going into the next question. So Natalie is a swimming instructor, is paid $27.60 an hour. So we were working 15 hours of normal time and 6 hours of time and a half. So that's just simply doing the pay is going to be $27.60 times 15, so we've got the 15 hours of normal time, plus the $27.60 times the 6 hours of time and a half. And remember, time and a half is just 1.5. And when you put that into your calculator, you get $662.40. Pretty basic. Here we have Ethel had a budget of $200 of fuel for her trip, and the price, blah, blah, blah. Her car has a fuel consumption of 6.2 litres per 100 kilometres, and she paid $1.79 per litre for her fuel throughout the trip to the nearest kilometre. How many kilometres was she able to travel? So what we first want to do is, by using the total amount of money that we could use and then the price of the petrol per litre, let's try to figure out how many litres of petrol were used. So we've got 200 divided by 1.79, and that gives you 111.73184 ... And that's telling us that's how many litres were used. So now that we've figured out how many litres were used, we can now divide that by 6.2 and then times it by 100 to show us how many kilometres were travelled. So we have 111.73184 ... As always, making sure we're not rounding until we get to the end of the question. Divided by 6.2, and that gives us 18.02126, blah, blah, blah. And then just getting that number, 18.0212 ... times it by 100, and that gives us 1,802 kilometres, and that's to the nearest kilometre. So it's a matter of getting that total amount of price, dividing by the price per litre to calculate how many litres are used. Then we're seeing how many lots of 100 kilometres were travelled. So that's just getting that amount of litres divided by 6.2. So what this is basically saying is there was 18.02 lots of 100 kilometres were travelled. So we're trying to find how many kilometres that is, and that's it. Now going to this question. So we have these two places, Prince Edward Island and La Palma. So what is the difference in longitude between these two places? Well, longitude, remember, that's the east-west, not the north-south. So simply what we need to do is 63 minus 18, and that equals 45 degrees. Pretty simple. That's the difference in longitude. And then so we now need to figure out the local time. In Prince Edward Island when it's 10 a.m. in La Palma. So what we're going to do first is let's find out the time difference. So sometimes you're told the Greenwich Mean Times and you can just find the difference. This time we're told the longitudinal difference, and we know that for every 15 degrees of longitudinal difference, it's 1 hour time difference. So 45 divided by 15 equals 3 hours time difference. And now using remember, it's always helpful to put these things on a number line. So we know that so we're told that La Palma is 18 degrees west. So here's our 0. Remember, we're going in a westerly direction. So this is our La Palma, and this is Prince Edward Island. So we know it's 10 o'clock here, so that means we're going backwards. And remember, when we're going backwards, we're going to subtract that time difference, okay? So that means we're just going to get that 10, we're going to minus it by 3 degrees, and that gives us 7 degrees. So therefore, 7 a.m. Alright, so the key thing to this question here is getting that longitudinal difference, dividing it by 15 to find the 3-hour time difference, and then subtracting by 3 hours. Alright, going on to the next page. Alright, so in this question we have to do 2 conversions. So Davis is shopping online, he's looking at items in various currencies. Davis knows that it's currently $1 Australian dollar is equivalent to 75 US cents. And here's we've got this graph as well. So Davis decided to purchase an item costing 40 euros, use the information given to determine the value of Davis's purchase in US dollars. So we have 40 euros and we want to get to US dollars. Now we don't have a direct conversion between euros to dollars, but we can go from euros to Australian dollars using this graph. And then once we've got Australian dollars, we can change to US dollars. So 40 euros, going across here, we get to about there. And then going down, you can see it's just like a little bit past halfway. So I'm going to say at 66. I think at this kind of question, that's where, like, if you said 65, that would also be fine. So we're told that 40 euro equals 66 Australian dollars. And now that we have 66 Australian dollars, we're told that for every Australian dollar is 75 US cents. So therefore, we can just get our $66, timesing it by 75 cents, and that gives you $49.50. And like, if you were to do, like if you read that as 65 Australian dollars and you did 65 times 0.75, you'd probably get the exact same. Well, you wouldn't get the same answer, but you would still get the 2 marks because it might be a bit hard to read on the graph. Going into question 21. So in height, the centimeters of the 12 players and the Australian netball team are blah, blah, blah. So what is the mean height of the Australian netball team? Well, mean height, just find the average. You're going to get the average to be 184.5. I'm not going to go through the process of finding the average there. And now we would need to construct the box plot for this data. So this is 3 marks because what we're going to need to do here is find the quartiles, the median, and then actually sketch the thing. So here we have 12 players, first of all. You could just remember on newer calculators, you can actually just find the lower, like all the different, like the 5-number summary, and then just go from there. And that's totally fine if you want to do it that way. But these are only 12 numbers, so I might just do it on paper as well. So we have 12 things. So the middle here is going to be here, and that's Q2. And that's 186 because we're looking at the number that's between 105 and 187. From there, we kind of now split this data into 2 halves. So now the halfway of this first bit is 180, and that's Q1. And halfway of the second bit is 190 because it's a number between 190 and 190. And then obviously Q4 is 195 and Q1 is 168. And then from there, all we need to do is just create the box plot. So 168 is about there, 180 is about there, 186 is about there, 190 is about there, and 195 is about there. And then from there, it's a simple matter of connecting the box on those ones and creating the whiskers on those ones. So you're just taking your 5-number summary and putting it into a box plot like that. Going to this question, we just need to find the perimeter of this shape and then times it by 52 meters, $52 because it's $52 per meter. So to do that, what we're going to first need to do is find the length of this. So I'm just going to call this x, and we know that this is 4.8, and we also know that this is 4.8. So this is a hypotenuse of a right angle triangle. So Pythagoras' theorem. So x squared equals 4.8 squared plus 4.8 squared, and that equals 6.7. Well, when you do that and then square root it, you're going to get 6.78822 ... So now that we have the distance of that, and again, no rounding until we get to the end of the question. So therefore, the perimeter is just going to be 1, 2, 3, 4 lots of 4.8. We're not counting this one in the middle because that's not part of the fence, the boundary. So we have 4 lots of 4.8. And we're going to also add that other number, the 6.78822 ... And that gives us 25.98822 ... And now that we have that, we now need to just multiply that by 52 meters. So therefore we do 52 times $52, sorry, 25.98822 ... which equals $1,351.39. So we get that. Just note there was another question in like some past HSC where you actually had to round it up to 26. You don't need to do in this question because the question doesn't specifically say you can only buy them in meter lengths. Here it's just saying it's $52 per meter. It doesn't say we can't buy 0.98822 of a meter, so we can just use that. That's fine. All right, going into this question now. This is a nonlinear relationship that we need to sketch and then interpret. So we're told, we get given this quadratic equation, and we just need to put these numbers in 0, 2, 4, 6, and 8. So when you put these in, you get 1, 13, 17, 13, and 1 again. And then so when we put in these numbers, so this is 2, 4, 6, 8. So we have 0, 1, 2, 13, 4, 17, 6, 13, and 8, 1. And then so all we need to do is make a nice parabola shape like so. Okay, we know that it's a parabola, and we also know that it's a concave down parabola because up here it's t squared with a negative in front of it. So the negative makes it go concave down, and the t squared shows you that it's going to be a parabola. And then, so for how long after being thrown does the ball reach its maximum height? Well, the maximum height is clearly there, and that's after 4 seconds. So fairly simple, 4 seconds. Going to the next question. So this is just a simple network where you just got to create a network and put in the values for each. So this has 4 vertices. So I just tend to just put them into a square. So A, B, C, and D. And then it just turns out that everything has a connection. So A to B is 10. A to C is 21, and then A to D is 7, B to C is 26, and B to D is 16, and then C to D is 18. All right. It doesn't matter if the edges overlap because it's pretty easy to see that this one is 21 and this one is 16. Just as long as you don't put a dot in between, it's known that they don't cross. And then from there, so Sarah began to deliver at Auburn, and then went to Dundas, Chatswood, Bankstown, and then returned back to Auburn. So all we need to do is just add the weights of each of these edges. So 7 plus 18 plus 26 plus 10, which equals 61 kilometers. Really simple, that one. All right. So this one here, we have Harry and John are brothers that live 3 kilometers from the school. Harry walks to school at an average speed of 5 kilometers an hour, and John rides his bicycle to school at an average speed of 12 kilometers an hour. So if Harry leaves home at 8:10, what time must John leave home so that he arrives at school at the same time as his brother? So let's just work with Harry first of all, and if it helps, always just refer back to this DST triangle. Okay, so in this case, let's just work with Harry first. And with Harry, we just need to find, he leaves home at 8:10. So what we want to do is find out what time does he get to school, right? the way that we're going to do this is find out, well, how long did he need to ride? So we know that they're 3 kilometers away, and Harry walks at 5 kilometers an hour. So if we do 3 divided by 5, that gives us 0.6 hours. But we might as well change that into minutes, so it's 36 minutes. So that means it takes Harry 36 minutes to walk to school. So therefore, he's arriving at 8:46 a.m. Okay? So now that we know when Harry will arrive at 8:46, we now can work backwards so we can find what time John needs to leave so that he also arrives at 46. So looking at John, this time we're still traveling that same 3 kilometers except a little bit faster. So 3 over 12 is 0.25 hours, and that's 15 minutes. And so now we know it's going to take him 15 minutes to get to school, and if he needs to arrive there at 8:46, it's simply subtracting. So 8:46 minus 15 minutes, so therefore leave at 8:31 a.m. because we know we've calculated it's going to take him 15 minutes. So to get there at 8:46, he needs to leave at 8:31 a.m. All right, going into this next question. This just has a bit to do with shares. So what we first want to do, we're told that Tim purchases 500 shares at $2.35 per share and later sold them for $3.50 per share. Tim paid brokerage fees on the purchase and the sale of the shares as shown in the table below. Given that he did not receive any dividend, and that's just kind of saying you don't need to factor anything else other than the price and the brokerage fees, calculate the profit. So we need to find how much he paid for to buy the shares and then how much he got out once he sold the shares, including the brokerage fees, and just subtract the two. So let's focus on the cost first of all. So the cost of the share is fairly easy. It's 500 times $2.35, which equals $1,175. And then the broker fees is 2% of that. As you can see here, the purchasing is 2% of the fees. So 2% of that number, 1175, which equals $23.50. So therefore, the total purchasing price was $1,198.50. So that's just, those two added. The cost of the shares plus the brokerage fee. Now let's focus on the sale now. So we sold the shares at 500 times $3.50. which equals $1,750. But we also need to factor in the brokerage fees again. So broker fees, so 3% of $1,750 equals $52.50. So that means rather than in this case, we added the two because these were costs, but this time he's getting an income of $1,750, but he still needs to pay this. So we're going to subtract these two this time. So therefore, total sale, the total income that he's getting is this minus this, which gives me $1,697.50. And then to finish this off, well, we need to find the profit. So it's going to be simply this minus this. So therefore, the profit equals $499. Just this minus that. All right, going to the next page. So we have these 3 points, and they're in a rectangular playground. And so we're also given this information. That's 80 meters, that's 70, that's 60. And from that, fairly easily, you could say that's 50 because it's a triangle. It needs to add up to 180 degrees. So calculate the distance between B and C. Give your answer correct to the nearest meter. So here we have a non-right angle triangle where, let's just call this X. So we have 2 sides and 2 angles. And we did actually need to find that 50 degrees because if we're going to use sine rule, we have this 80 meters. We need to use the angle that's opposite it. So when you set up your sine rule, I'm going to just call that X. So X over sine 70 equals 80 over sine 50. And then, so what you do from here is you just multiply the sine 70 over and put it into your calculator, and you'll eventually get x equals 98 meters to the nearest meter. And again, as always, making sure you're taking note of what we need to round to, so correct to the nearest meter. Okay? So now that we know that this is 98, what we want to do is find the width of the playground, and that's this line, or this one, doesn't really matter, but might as well focus on this one. So I'm going to call that y, and then I'm just going to, what we've got here is, we know it's a rectangle, so we know that's a 90 degrees. So from here, I'm going to just put in the information that I have. I now know that that's 98, and I can just use the rounded number because in the previous question I said that's 98, so I'm just going to use 98 here. And here, if I know that that's 60 degrees, that means I know that that's 30 degrees. So we've got 30 degrees in here, and I'm trying to find this length y. And now here I just have a right angle triangle, SOHCAHTOA, so cos 30 equals y over 98. Simply just multiply the 98 over and put it into your calculator, and you get y equals 85 meters, and again, correct to the nearest meter, so to nearest meter. Okay. Looking at question 28, and this is about z-scores. Alright, so the weight of babies born in a hospital were found. Sorry, give me a sec. Yeah, cool. Sorry. Yep. So the weight of babies born in a hospital were found to be normally distributed with a mean of 3.5 and a standard deviation of this. So we got x bar and we have s. And here we have Raphael was born weighing 4.2 kilograms. What is the value of the z-score of this birth weight? So this is just finding the z-score. So z equals 4.25 minus 3.5 over 1, and that's 1.0 or 1. So 4.25 minus 3.5, and that equals 0.75. Pretty simple, that one. Now going to this one, a baby is considered to have very low birth weight if they are born weighing less than 1.5 kilos. Given that 2020 the hospital recorded 8 babies born in that range, how many babies would be expected to have been born in total in the hospital last year? Alright, so let's first of all find the z-score of this. So the z-score of 1.5, you'll find this to be -2 once you put it in. And so we're saying that anything that's weighed less than that, so anything less than a z-score of -2 is that. So we know that, everything between a z-score of 2 and -2 is 95%. That means outside of that is going to be 5%, but we're only factoring in half of that. So that means the percentage that's less than 2, a z-score of -2 is 2.5%. So what we're told then is 2.5% of all the babies that were born that year were very low birth weight. So that means 8 of whatever it was is, 2% is 8. So that means 1% is 3.2. So this is just following the unitary method. So divide by 2.5, divide by 2.5. And then we're going to times by 100. So 100% equals 320. So therefore 320 babies were born. Okay, so this is following your unitary method. Going to this question, rearrange the following equation to make A the subject. This is actually a relatively easy one to change the subject. So we want to get A by itself, and remember the rule is we kind of want to move the thing that's furthest away first of all. So let's get rid of the B first of all. So I got CB equals x squared minus A. Next, there's 2 ways to go about it from here. What I want to do is I need to get positive A by itself. So what I'm actually going to do is I'm going to add the A to the other side now. So I have A plus CB equals x squared. The reason why I've added that to the other side is just so I can make it positive. And now to get A by itself, I just need to subtract CB. So I get A equals x squared minus CB. And that's fine. What you could have also done is instead, from here, I could subtract the x squared over. So now I have CB minus x squared equals negative A. And then to get rid of the negative in front of it, I'm going to make everything negative on the other side. So divided by -1 basically. So I'll get negative CB plus x squared equals A. And that is the same as that, just in a different order. That's positive x squared. That's positive x squared. That's negative CB. That's negative CB. All right. All right, going into this next question, and when I saw this question, I was a bit surprised because it's just trapezoidal rule doing it 4 times, and I think that's kind of a waste of time. But anyway, so what we need to figure out first of all here, though, is that this whole thing is 50 meters, but if I'm going to be doing 4 applications of trapezoidal rule, that means I need to divide that 50 meters into 4 parts. So that's 12.5, that's 12.5, that's 12.5, and that's 12.5. So I'm just going to do the trapezoidal rule for this first one, but what we need to do is find the area of each of these parts. So the area of the first one is approximately equal to 12.5 over 2 times 19 plus 22, and that gives me approximately 256.25. And now, of course, what you got to do is just do the same thing for the exact same process for these other 3, and then you're going to add them all up together. So therefore, the total area, once you do all that, you'll find the total area to be 1,000, approximately equal to, of course, 1,081.25 meters squared. All right, so I kind of skipped a bit of that. And then lastly, so we need to express the shaded area as a percentage of the total area. Well, we're told that this is 50 meters by 50 meters right at the start of the question. All right, we're also told it's a square plot, and that's 50, so you know that's 50. So that means the total area, or the square. I don't want to call it total area because I just did, so shaded area. So the total area is 50 times 50, so that's 2,500 meters squared. We want to write that shaded area as a percentage of that. So all we need to do is get that area 1081.25 divided by 2,500 times it by 100, and that gives me 43.25%. What we're saying there is this shaded area takes up 43.25% of this whole area. And just looking at the diagram, even though it's not to scale, you can imagine that to be true. It's just a little bit less than half, which is always a good thing to do. Just check to see if that makes sense in the context of the question. All right, looking at this question. So this is just an annuity one where we need to find the interest at the end rather than the final value. So we're told that depositing $2,200 into an annuity account at the end of every year for 4 years, and then 3% per annum interest compounding annually. So because this is per annum compounding annually in years, it means we actually don't need to do any conversions. We just got to look at these numbers. So we've got 3% 4 years, using that number there, 4.1836, sorry. And we're just going to get that and times it by that. So the future value is going to be 2,200 times 4.1836, which gives me $9,203.92. But what we want to do is find the interest. So we're not trying to find the future value. That will give you probably like 1, maybe 2 marks. Actually, that would give you 2 marks, but we need to find the interest. So therefore, the interest is equal to that amount, so that $9,203.92, subtracted by 4 lots of 2,200, and that gives us $403.92. 4 lots of 2,200 because we're putting that in the annuity for 4 years. So, yeah. All right, look, in this question, the network shows the maximum possible flow between the vertices. Draw the minimum cut on the network diagram and calculate the maximum flow between the sink and the source and the sink. So this is using the max flow min cut theorem. All you're going to need to do here is just do a bunch of cuts and see which one is going to be the shortest. So in here, I'm just going to do a bunch. So if I try to cut here, that's 12 plus 8 plus 10, so that's going to be 30. So we'll just keep that in mind. If we try to chop here, that's going to be 20 plus 12, and that's 32. If I try to cut here, for instance, now this is a key thing here. This is starting on the source side and ending on the sink side, so we do count this. We'll count this as well, but we're not going to count this cut. Remember, we only count the ones that start on the source side and end on the sink side, and this one here doesn't. So this is going to be 20 plus 6, that's 26, so that's pretty good. We can look at a couple more. So maybe if we try to cut here, 15 plus 8 is 23, plus 6 is 29, so that doesn't help us anymore. We could also try cutting here. So 12 plus 8 is 20, plus 6 is also 26. And you can keep doing a couple more cuts to see if there's anything shorter, but you'll find that there isn't. And so that means realistically, there's actually two answers to this. You could choose this one or this one, but as long as you say the maximum flow is 26, all you got to do is get the weight of that smallest cut, and that's going to be the maximum flow using the max flow min cut theorem. All right, going into this question, this is a bit of a longer one, but it's in terms of difficulty, it's not too bad. All we need to do here is follow this recurrence relation. So what we're saying is we have this $50,000 and we're making $750 repayments with this interest rate at the end of each month. We've got to use this recurrence relation. So A1, which is basically telling us how much is owed at the end of the first month, is equal to the principal, or A0, so $50,000 times 1.0025 minus 750, and that equals $49,375. Now A2 is you just do the same thing, so we now get this number, 49375, 1.0025 minus 750, and that equals 48748.44. All right, and then we just do it again for A3. I'm not going to do the whole thing again, but at A3 you get 48120.31. And then lastly, what we need to do is find, we're not actually trying to find how much is worth, how much is left over after the third month. We're asking how much was paid off. All right, so obviously if that's how much is owed, and this is how much it started with, we just got to find the difference between the two. So therefore, paid off equals that $50,000 that we initially had minus the $48,120.31 that is now owing, and that gives us $1,879.69. All right, going into this question, and I'm just going to kind of be very brief about this one because I'm not going to go through the whole process of doing this on your calculator. But a football coach is studying the relationship between the weight in kilograms of players and their vertical jump in meters. The coach believes that players who weigh less are able to jump higher. What that is saying is as this W increases, V is supposed to be decreasing. Okay? Because as we're saying, ones that weigh less jump higher. So because we're saying as W increases, V should be increasing, what he's saying there is a negative correlation, and we'll get back to that in a second. Anyway, find the equation of the least squares regression line, give your each value correct to 2 decimal places. I'm not going to go through this process. You've probably seen enough times now to know how to do this. All you got to do is just put it onto your calculator and use those buttons. So we're going to get V equals 0.03 W plus 18.75. Now you should be using V and W, but if you go into autopilot and use Y and X, it should be fine. Now by calculating Pearson's correlation coefficient for the data, correct to 3 decimal places, justify whether the data confirms the association between weight and vertical jump. So here we get R to be 0.199, and as we know, that's so weak that it's not statistically relevant. Generally, we say that anything between negative 0.25 to 0.25, we say there is no association or there is no relationship. So you could just say that and say, well, there's no real association between weight and vertical jump, and that would be good enough. Also, like I was saying though, where the coach is saying that if you weigh more, you jump less. So he's kind of inferring that there's a negative correlation, where we can see here that there is a positive correlation. It's a very weak positive correlation, but it is still positive. So therefore, you just need to say it's positive instead of negative or something like that. He's saying, the coach is saying it needs to be negative, but we've seen it to be positive, so it's not true. All right, going into this question, and this is actually a bit of a trickier question because it's like a very small part of the syllabus. Yeah. So we have 2025 kilojoules, and we want to change this. We want to convert that consumption into watts. Now, one thing that we can say is 1 watt equals 60 joules, because what we want to do, what a watt is the amount of joules used per second, right? So that means, so we're going to basically change this to 2025000 joules, because kilo, 1,000, I've just times that by 1,000. So we're going to get that amount, 2025000. We're going to divide it by 90, because we've got 90 minutes, and we're going to divide it again by 60, because we've got 60 seconds in every minute. So like it's the amount of joules is the amount of, watts is the amount of joules used per second, and we get 375 watts. So now that we've got this 375 watts, we want to calculate the cost of running the machine for 1 hour. So we need to find the kilowatt hours. So per kilowatt hour, so we need to change that into kilowatt hours. So we have that equals 0.375 kilowatts. So therefore, we're going to get that 0.375 watts. We're going to times it by 1 for the 1 hour, which I guess you don't really need to do, but that's the amount of kilowatt hours, and then we're going to times it by the price of 0.3159, which gives us 12 cents. So it costs about 12 cents to run this washing machine for 1 hour. Going into the next question. So here's a probability question where bag contains 7 black and 12 red counters. Two counters are selected at random without replacement, and that's really important because that's going to change the probabilities at each stage. And in this first one, we just need to show the probability of each of the 4 possible selections of the second counter. So if I chose black first, that means there's only going to be 6 left on the second out of 18. Whereas if I chose black first, there's still the 12 red remaining out of 18. Remember the way that we could check it, like this is without replacement, so obviously there's 1 less. So 8 over 18, there's 1 less black. And then remember 6 over 18 plus 12 over 18 has to equal 18 over 18 to know that you're factoring for everything here. Similarly here, if I chose a red one first and then that means the probability of me choosing a red one second is 11 over 18, and then me choosing a black second would be 7 over 18 because I've still got the original 7 black counters here. So remember, this is like if we chose a black first, it changes the numbers in this way. If I chose a red first, it changes the numbers in this way. So by using the probability tree or otherwise, determine whether Lucas is more likely to find 2 counters of the same color or different colors. So probability of the same means that we're finding the probability of red or black, right? So if we're looking at black, that is 42 over 342, and red is 132 over 342. So when you add those two together, this plus this, you're going to get 174 over 342. So that means the probability of them being a different color. Well, we could just find the probability of black-red and then red-black and then add them together, and that's totally fine. But obviously, these are also complementary events. So we could also just do 1 minus 174 over 342, which would give me 168 over 342. And just comparing these two probabilities, getting the same color is more likely. So therefore, same color is more likely. Alright, going to this question. So graph the following pair of equations and identify the coordinates of the point of intersection of the two lines. So fairly easy one if you're good at drawing linear equations, and seeing that we've been doing that since year 7, probably should be. So let's look at this one first of all. We can see that the y-intercept is at 4 and the gradient is 1 over 2. So that means I can go up 1 across 2, up 1 across 2, or maybe down 1 across 2, whatever. And then once you've got a few points in there, just go ahead and sketch that line. Cool, that's the first one. And what you should get in the habit, particularly if you're labeling more than one, drawing more than one, is make sure you just label them as well, just to be clear that this is this one. Also having the arrowheads. And then for y equals 2x plus 7, so we'll just, y-intercept is at 7, we go up 2 across 1, and then there we go. You can quite clearly see what the point of intersection is going to be there. And again, these lines, you really should be using a ruler. If you don't have a ruler in your HSC paper, then use the side of a pen, but you should have a ruler. And then obviously you can see that point of intersection here is negative 2, 3. Not too difficult there. All right. Now this question here, this is creating a network, like an activity diagram. And this is where, these ones can get really quite messy. What it's always good to do to remember to start off, and I'm just going to skip it a little bit, but I'll talk about things to consider. So what you need to do first of all is think about what are the starting activities. So we can see on the diagram, these two don't have prerequisites. So that means A and B are our starting activities. So here's our start, and then A goes this way and B can go this way. All right. And then we also can look at what's going to be our finishing points. Remember, the ones that are going to be at the finish, so we just got our one finishing point. The finishing points are the ones that don't show up in the prerequisites. So I, it doesn't show up in the prerequisites, and H doesn't show up in the prerequisites. So that means I and H are my two finishing activities. All right. So that's H, and that's I. Now that we've got that, we can now just start making our way up the network chart to start creating it. So I, the two things that come out of I are F and G. So we've got F, and we have G. Then what's coming out of H is C. And then out of G is B. So straight from here, we now that one of the starting point is G, so we can kind of, just connect these two like this. So now we have B goes to G goes to I. So that's pretty good. Out of F is coming D and E. By the way, I kind of glanced over this, but you can see that there's going to be no need for any dummy activities, because even though there are some activities that are repeated, like A and A, B and B, there are no activities which are repeated but not identically. So for instance, there's AA and BB. It's not like there's an AB, which would mean that we need a dummy activity. So that's pretty handy for this one. So we've got G, F, out of F is E and D. Yeah, this will do. So we've got E and D. Now E comes from B, so we can actually just connect this. and D comes from A, so we could kind of just put this here, and then C comes from A as well. Finishing that up, and now we have all our things on there. So not the prettiest diagram in the world, but it still does have all the prerequisites and everything good to go. Now what we just need to do from here is we now also need to find the earliest starting time and the latest starting time of each of these, and this is where it gets just even more ugly. So here's our start, here's our finish. So A, first of all, let's just write the weights of each of these as well. So we've got 7, C is 4, D is 2, E is 3, F is 1, G is 1, H is 5, and I is 3. And then going from here, let's just start doing the forward scanning. So starting at A, it's obviously 0, and for B, it's obviously 0 as well. Then C, so this is for C, starts at 3, because it's after the 3, and then D, the earliest starting time is also 3. I might just put this down here, because it's after the 3 for that. Now, the earliest starting time for E is 7, and the earliest starting time for G is also 7. Now, the earliest starting time for F, we now have a decision that we need to make here, because we can either look at the 3 plus 2, which is 5, or we could look at the 7 plus 3, which is 10. So it can either be 5 or 10. And remember, when you're doing the forward scanning, we always choose the biggest one. So it's going to be 10. And then now, again, we have a choice for, well, for H, it's pretty simple. 3 plus 4 is 7. And then for I, we now have two ways that we can get into I. We can either go 7 plus 1 is 8. Or we could do 7 plus 3 plus 1, which is 11. So again, we got to choose the biggest one. And then lastly, for the finish, we only need one box for this. We can either do 7 plus 5 is 12, or 11 plus 3, which is 14. So of course, we need to finish with 14. And now we've done the earliest starting times, and now we start with we've got to do the latest starting time, and that's just going backwards and reverse and subtracting these numbers. So 14 minus 5 is 9, and then 9 minus 4 is 5, and then 4 minus 3 is 1. So that's that one done. And then 14 minus 3 is 11. 11 minus 1 is 10. 11 minus 10 minus 3 is 7. And then 11 minus 1 is 10. And then 7 minus 7 is 0. So we kind of just like went through all the piles and did the backward scanning. So 4 marks for this. But as you saw, it took quite a bit of time, and the 4 marks are kind of from, doing the diagram, making sure all the connections are right, finding all the earliest starting times, finding all the latest starting times. So quite a lengthy question for 4 marks, but it was. And now we need to list the activities that make up the critical path of this project. Remember, the critical paths are the things where the float time is 0. So that's B, then E, because that's 7, 7, then F, which is 10, 10, and then I, which is 11, 11. So that 1 mark's quite easy once you've got this thing. But remember, there's going to be one critical path where the earliest starting time and the latest starting time are equal the whole way through. So 0, 0, 7, 7, 10, 10, 11, 11. Oh, I forgot to do this one. This would be 10 minus 2, so it's 8. Make sure you don't forget that one. All right, going into the next one. So we're told that a farmer is purchasing a tractor for $54,000. The tractor depreciates by a declining balance method of depreciation at a rate of blah, blah, blah. Calculate the value of the tractor after 10 years. So this is just salvage value equals $54,000 times 1 minus 8.3 over 100. Remember, this is depreciation, so it's minus. and that gives us $22,703.20. And then this one here, so a farmer's taking out a loan to purchase the tractor. The loan repayment is $723 paid monthly over 10 years. So let's find the total repayment first. Equals, and that's just the 723 times by 10 times by 12, which gives us $86,760. So calculate the equivalent annual flat rate of interest corrected 2 decimal places. So what we want to do here is we're going to use simple interest, like in reverse, to find the interest rate. So we have the total that paid, and then the principal, the original value is $54,000. So therefore we can find the interest that was paid. So the interest is going to be that 86,760 minus 54,000, and that equals $32,760. Now that we've got that's the amount of interest, we can now put this into our simple interest formula. So 32,760 equals the principal 54,000, times by the rate, times, and that's the thing we're trying to find, and then timesing it by 10 because it was over 10 years. So what we now need to do from here is just get that, divide by that, and we get R equals 0.060666 ... Now that's R written as a decimal, so that means the percentage or the rate is going to be equal to 6.07% to 2 decimal places, and making sure that you convert that into a percentage at the end. That's simply timesing it by 100. All right, just a couple more questions left. I think this is second last page. Yes, it is. All right, so Ella contributes this much at the start of every month in investment accounts, pays 3.2% per annum compounded monthly. Show that at the end of the second month, the future value of Ella's investment will be that amount. So this is kind of like one of those, it's an annuity, but we don't have like the annuity table. So we just need to do like 1 month at a time. So what I tend to do with these questions is just set up a table. So I'm doing it for only 2 months. The principal of that month, I want to find the interest for that month, and then the value at the end of that month. All right, so at the start of the first month, of course, there's $1,200. All right, at the start of each month, there's that. And so we need to find 3.2%, except that's compounded monthly, so we need to find 1/12 of that. So 3.2% over 12, and then times it by that, and that will give us $3.20. And so therefore, the value in this account at the end of that month is going to be $1,203.20. Now that number isn't simply just going to go into there, because we're saying that we're putting in that much money at the start of every month. So we're going to get that amount plus another $1,200. So now we have $2,403.20. And again, we're going to find the interest of that now, which is $6.41. And then when you add those two together, you get $2,409.61, which is what we're looking for. So therefore, there's $2,409.61 at the end of the second month. All right. So I've just did that as a table, but there's lots of different ways of doing that. You can do it a bit more, I don't know, arithmetically. So after 18 months, the future value of Ella's investment will be that. Beth has a lump sum of that amount, which is equivalent to the total of Ella's contribution, but she wants to just put that money in one chunk and just let it grow. So how much more than Ella will Beth have after the investment has been finished? So this is just a compound interest question. So future value of that amount is 21,600 times by 1 plus 3.2 divided by 12 over 100, and that's to the power of 18. And then when you put that into your calculator, you get $22,660.64. And so the question is asking, well, how much more does she have? So you just need to get Beth's number minus Ella's number, which is this. So when you find the difference between these two, you're going to get, so Beth earns, and you get $505.08 more. Simply just getting that number subtracted by that number. All right, and the last question of the paper is we have this question where we have an arc and also this line, and the question is asking, well, how much longer is that arc than that line? So let's find the length of the arc first of all. So arc length, and we have the arc length formula. That's just theta over 360 times 2 times pi times the radius, which in this case, the theta is 50. So 50 over 360 times 2 times pi, and here's the radius is 1,200. And that gives us approximately 1047.197 ... And we'll just leave that there for a second. Now we also need to find the length of this. So I'm just going to call that x. And ignoring this for a second, this is just a non-right angle triangle. I mean, there are two ways of doing this, really. You could also do SOHCAHTOA, like cut in half, do SOHCAHTOA, and then times it by 2, and that would work. But we might as well just use cosine rule here. So I'm going to do x squared equals 1,200 squared plus 1,200 squared minus 2 times 1,200 times 1,200 times cos 50, and then you put that all into your calculator and you square root it. You get x equals 1014.28 ... And then so we just need to find, well, how much bigger is this and this? So therefore the arc is, you just subtract these two. This minus this is 33 millimeters longer to nearest millimeter. All right, because that's, again, what it's asking to do it between. Anyway, and end of the exam. So hopefully this video, in conjunction with the written solutions that I've made as well, would be helpful in going through each of these questions and, pause, rewind, go through it again. If you have any follow-up questions about anything that's been said in this video, be sure to ask. Overall, I think this paper was pretty good. It covered pretty much every topic. There weren't anything that was too crazy difficult. So you might, it's always worthwhile looking at past HSC papers and past trial papers as well to get an idea of other kinds of questions that can be asked. But yeah, hopefully this was helpful. If you have any more questions, be sure to ask. Thank you.